Hi, welcome to this video on Year 7 Equality and Equivalence. So this is aimed at Key Stage 3 maths, okay, and also Key Stage 2, and it may also be appropriate for GCSE foundation students for all exam boards and for the IGCSE and the WJEC and CIE exam board for the foundation tier. We're going to start with question number 1. Complete the fact family for this bar model. I've got 8 and 4, okay, is 12. So 8 plus 4 is 12. Well, I can also say that 12 is equal to 8 plus 4, right? Because 12 is same as saying 8 plus 4. I could also say on this one that 12 is equal to 4 plus 8. Okay, and for this one I can say that 4 plus 8 is equal to 12. So the idea behind this is that I can write my sums in different ways and still get the same answer. So it's understanding the idea that things can be rewritten but give me the same answer. For example, I can say that 12 is equal to 4 plus 8, or I can say 12 is equal to 8 plus 4. Okay, it means the same thing. So rejigging the numbers around, okay, provided that I'm keeping the facts the same, will give me the same answer. Okay, question number 2. Complete the fact family for this bar model. 28, and then I've got 4 lots of 7. 4 times 7 is 28. Therefore, 7 times 4 is 28, because I've got 7 lots of 4. I've got 7, add 7, add 7, add 7. Okay, and then I can say that 28 is equal to 4 times 7. Okay, and that 28 is also equal to 7 times 4. So these are all the same sums, but the idea is that it's rewritten in different ways, because sometimes a problem might be presented to you in a slightly different way, but it's you recognizing that it's just rewritten in like a different format. That's all it is. This is question number 3. Solve these equations. A plus 37 is 83. Well, if I subtract 37 on both sides of my equations to balance it respectively, okay, 83 take away 37. Okay, so putting everything under the correct place value, 3 take away 7 I can't do, so I have to borrow. That becomes a 7, and that becomes a 1 there. 13 take away 7 is 6. 7 take away 3 is 4. So the answer is 46. This is the second question. 24 equals b minus 6. Well, if I add 7.6 to both sides of my equation to balance it respectively, okay, so 24 add 7 is 31, and then adding that 0.6 is 31.6. Okay, so the point is there, guys. Sorry if it wasn't very clear. Next question. C divided by 9 is 40. Well, the opposite of divided by 9 is to times by 9. So we multiply by 9 on both sides of my equation to balance it. 4 times 9 is 36. And then adding the 0 becomes 360. Okay, the next question, 60 is equal to 5d. Well, if I divide both sides by 5 to balance the equation and isolate the letter by itself, because I'm trying to isolate and get the letter by itself, okay, 5d means 5 times d, so the opposite of times by 5 is to divide by 5. 60 divided by 5 is 12, so 12 is equal to d, or I can just rewrite that as d is equal to 12. Okay. Next question, question number 4. Make up an equation which has solutions x equals 7. Well, if I say x minus 7 is equal to 0, okay, if I solve this equation, I'll get the value x equals 7, because 7 take away 7 is equal to 0, which is correct. This is question number 5. Sam thinks of a number. She subtracts 87 from his number and gets the answer of 254. Show this information as an equation. So I've got a number x, take away 87, and I get 254. If I'm to solve this equation, well, if I add 87 to both sides of my equation to balance it respectively, so 254 plus 87, okay, and again I can do this as column addition, okay, making sure that all my place values are under the same place. 4 add 7 is 11, so 1 carry the 1. 5 add 8 is 13, add the 1 is 14, so 4 carry the 1. 2 add nothing is 2, and then add the 1 there, becomes 3. So the answer that Sam is thinking of is 341. This is question number 6, guys. Sort the following into 2 sets of like terms. So like terms means that I collect all of my letters in one set and all of my other letters or numbers into another set. So set 1, so let's put all of my x's in here. I've got 5x, I've got x, I've got 2x, and I've got negative 5x. Okay, these are what I call like terms because I can combine these together. So cross that off, cross that off, cross that off, cross that off. The next set will be the numbers, minus 5, comma, and then 5, okay? So these are my other sets, okay, of like terms, because I can combine the numbers together and I can combine the x's together. This is question number 7. Take the expressions that are equivalent to 5b. Okay, 3b add 2b is 5b, so that's correct. 6b take away 1b is 5b, that's correct. 5 plus b is not actually equivalent to 5b. Okay, 5 times b is equivalent to 5b. That's right. B plus B plus B plus B plus B, that's equal to 5b, so that's correct. That's b divided by 5, written as b over 5 as a fraction, which is not equivalent to 5b. Okay. This is question number 8, guys. Simplify these expressions by collecting like terms. Okay, so 4x plus 3x is 7x. Take away 2x is 5x. Okay. Next question. 5c, okay, doesn't simplify, so I'm going to have 5c there straight away. And then I'm going to combine all of my d terms together. Okay, 3d add 2d is 5d, add 8d is 13d. Okay, so I'm collecting all of my d terms together. Okay, next question, guys. 8t plus 2t squared minus 3t plus 2t squared. So combining my t terms together, 8t subtract 3t is 5t. And then 2t squared plus 2t squared is plus 4t squared. Okay. And I can't simplify that any further because I can't combine my t's and t squareds together. This is question number 9, guys. An expression has 4 terms. When simplified, the expression becomes 6x plus 3. What might the expression be? Well, I can have x, for example, plus 6 plus 5x minus 3. Okay, x plus 5x, remember that's equal to 1x. Okay, I don't need to write the 1 there, but hopefully you're happy with that. Plus 5x is 6x. 6 take away 3 is equal to 3. Question number 10, guys. Tim says that the following expressions are equivalent to each other. 2n plus 5, 5 plus 2n. Is Tim correct? Explain the answer. So the answer is yes. Okay. 2n plus 5 is just the same as writing 5 plus 2n. It's just been rewritten in like a different way. Okay, I've got positive 2n there, and I've got positive 5. And if you look at my signs here, I've got plus 5 there, I've got plus 5 here, I've got plus 2n, I've got plus 2n. So they are equivalent to each other, okay? So Tim is correct, yes. Okay? So that is my answer for that question, guys.